Hi everyone, I'm Victor Sanh. I'm a research scientist at HuggingFace, and tonight I'm going to talk about how at HuggingFace we deploy state-of-the-art machine learning into production. But before, I want to introduce HuggingFace. So basically, we're building an entertaining conversational AI. So it's basically an AI who you can talk with. Here's the voice version, so you can actually call your AI and talk with it. So it's mainly designed for teens. So they talk about Justin Bieber, what they did at school, and how they hang out with their friends. But yeah, they talk a lot about almost everything. And the idea is that, yeah, it's like a long-term companion who you can talk with, like a pet, a dog, or a cat. But it's actually able to answer you. We have a pretty strong usage. Up to now, we have like more than 500 million messages exchanged. So that's a huge data set that we can leverage to train our own models on top of that. We have more than 4 million laughs and a bit more than 500,000 love declarations. So basically, teens saying, "I love you, you're my best friend," these kind of things. And on the way to building conversational AI, we're contributing a lot to the open source community, both machine learning and natural language processing community. So by that, I mean that we publish some research papers to top conferences, but we also release a lot of open source implementations. Some of them are here. But you should check out at GitHub or just talk to us. I'm here. We're also Clement and Harry in the back. But some of you have probably heard of BERT, which is like one of the latest breakthrough in NLP, one of the major breakthrough in NLP last year. So yeah, a lot of people are actually using it in production, so check it out. So for the rest of the talk, I'm going to talk about how what kind of challenges we face in terms of engineering, pushing machine learning models into production. But first, I want to introduce like the three main blocks, the three general main blocks for doing conversational AI. So generally speaking, the first block is natural language understanding. So what is NLU, natural language understanding, is actually to be able to understand what the user message is. So what's the intent? What is he saying? Am I able to extract coreference, relations, some name entities, some sentiment analysis also? And from that, we are going to switch from what I call dialogue state management. So dialogue state management is the fact that you want to be able to follow the conversation. So using the context, so the history of the messages, and what we were able to extract from the natural language understanding pipelines, where the conversation should be heading. And if I determine where the conversation should be heading, what kind of action should I take? And last, the last block is generally language generation. So I have decided where the conversation should be heading, and I have decided what action I should take. Now I have to generate an answer. So there are several approaches for doing language generation. Some of them, the most basic, are actually retrieval-based. So you have a huge data set of answers, and you just select one possible answer. But you can also do fully generative models, so letting the model generate an answer. So I'm going to mostly focus my talk tonight on the two first blocks, so natural language understanding and dialogue state management. So what kind of challenges do we face at HuggingFace when putting machine learning models into production? I would say we have three different kind of problems. The first one is inference time. So we all have this friend who's always like answering 10 minutes after that you texted him. And it's usually like 2 letters. The first one is O, the second one is K. HuggingFace is not this type of friend. HuggingFace, we're trying to answer really quickly. So it's usually in real time, let's say that. and we're not waiting like 1 minute to answer. The second thing is consistency through time. What if overnight I decide that I want to change completely my pipeline? And how do I ensure that I can do that without labeling any huge data set, without training from scratch a huge model? We can do what we call transfer learning, and that's mainly what we do at HuggingFace, leveraging transfer learning and all the data we have gathered. The third challenge is automatic pipelines. Basically, how can we produce more by doing less? So by leveraging all the data we have, but also leveraging our users. There are two things I'm not going to talk about tonight. Is model compressions to do more machine learning in production, and the other thing is hardware optimization. I will pass this to another talks. So keeping the inference times low. So 10% of our incoming message, so user messages, are actually yes or no, or variants of yes and no, like yup, yeah, and a lot of typos. So yeah, that's pretty much what they say, and that's pretty much what we say in real life too. When you answer a question, that's obviously one of the possible answers, or when you want to elaborate. So a good idea is actually to use cache, so you don't want to compute 1,000 times yes in a day. So it's always a good idea to use cache. Some of our pipelines are written in Python. Like, I love Python personally. It's like easy to develop. It's easy to jump in Python. But for many reasons, I can also argue that Python is not that efficient in terms of prediction settings. And what we can do is actually port the code to Python. So you can think of Python as a superset of Python that enable you to call C functions and C classes and basically a C backend. And that's pretty much what we did on some of our components. For example, the coreference module that we are using in production is based on Python. And we have observed up to 100 times, it was actually up to 100 times faster in production. The main reason is that actually coreference, it actually invokes some big O of n square operations. And Python is like much more efficient for doing that. How can we ensure consistency through time? So we use what we call transfer learning, which is a really classical, trendy technique in machine learning right now. The main idea behind transfer learning is that you have these huge data sets, and you're going to pre-train something on this huge data set. You're going to pre-train a huge model on these data sets. And then you have a smaller data set, labeled data sets, that you're going to fine-tune your model on. And it's usually super effective in the sense that it works pretty well for us, at least. And it's actually not that costly. So you have many strengths for transfer learning, many weaknesses. I guess that the strongest points for transfer learning is that it's completely unsupervised. So it means that you do not need to label data. So it's almost free to have this data set. So for text, you just scratch the web, and you have a huge corpus of text. Here we're using our own messages. I have more than 500 million messages, so it's actually enough to train something big. We use what we call language modeling in NLP. So language modeling is the task of predicting the next word. So it's not totally unsupervised, but it's like what we call self-supervised, since you have a sequence of text, you already have the labels, which are the next words. What is cool with language modeling is that it's a general objective function to train, meaning that the language modeling will learn a lot of different aspects from the text, which are coreference, relations, maybe some common sense too. But what I mean here is that it's sufficiently general that you can transfer it to other tasks, other specific tasks. And the third point is that when you have trained this huge, massive model on a huge data set, you can fine-tune really quickly on a smaller data set that you have labeled. And it doesn't cost much. So yeah, one of the weaknesses is that you need a huge data set, but again, it's not much of a problem. You just have to scrape a lot of text. And you kind of need a bit of computational power, but I think for most of us, it's not really a problem. AWS and Azure are doing a great job at this. And yeah, that's pretty much what we have in production, transfer learning, which enable us to leverage all the data we have and not label some other data sets. So there are many architectures, I guess, for doing language modeling. In the recent years, people have been switching from LSTM, so recurrent networks, to transformer architectures. There are many reasons for that. One of the main reasons is that actually transformers are able to model longer-term dependencies, at least longer than LSTMs, and is highly parallelizable, so it's easy to train compared to LSTMs. But I'm not going to dive into the architecture. It was introduced in 2017 by a paper called Attention is All You Need. But yeah, it has been like the main component of several language models that has been out there, like BERT or GPT from OpenAI. So this is the kind of thing we have in production. But you could ask why we do not just use what people have been doing, like BERT or GPT. And the answer is quite simple, is that actually teams use a lot of typos, use a lot of slang. They talk a lot about Justin Bieber and Kim Kardashian. So we want to be able to model these kind of things and to learn these things. So we actually leverage our data rather than using some Wikipedia or some text that is not relevant to our use case. How can we do more by doing less? So we want to leverage both our data and our users. And we have what we call automatic annotation. So we are leveraging our users to annotate themselves data without actually destroying the user experience. So if I say I went to school today, and the bot answer, are you saying you went to the office? No, I'm just a kid. Gotcha. So here is a negative example, but the idea is that the user can actually label the data themselves. Another thing is that we deploy quite a lot in a week, even in a day. So we have some pipelines, automatic pipelines to deploy for us. So if you think about it, the content change pretty often. The training sets also change very often. And what we do is that we trigger some signals that when these two change, we're actually triggering a training. So we have some production GPUs just for training. I mean, like GPUs just for production trainings. So it triggers the training, and then the weights of the new models are actually deployed to the servers and pushed into production. So you can think of it as pretty quick since we use transfer learning at the base. So it's just like a really shallow classifier on top of that. It's like almost nothing to train. Yeah, and that's pretty much it.
Would you rather rather yell or get a mic? Okay, go for it.
So you're talking to teams, right, mostly? Is there any parameters with which you limit the responsible language of your yeah? Like, can they talk about anything?
Yeah, they actually can talk about anything.
Do you censor them?
Sorry?
Do you censor them?
Do you censor them for talking about like inappropriate things?
We try to be really supportive in the sense that we are never gonna bully someone. We're never gonna insult someone. They can do it. They can insult the AI, but we're not gonna insult them back. Also, we don't have any limitations really on what the incoming message are, but we're definitely some limitations on what we are able to answer.
Do you have a list of some of the worst things you've seen? Yeah, can you read them off? Yeah.
Yeah, you see pretty much everything.
Thanks.
Could you repeat the question after this?
Oh yeah, sure. Sorry.
Yeah, that's no worries.
Yeah, I think there's a question.
So you got this whole machine learning pipeline and you train. What is the metric you use? Like, I guess, what's your definition of success for your machine learning algorithm? Because I know it's a conversational thing, so how do you measure success?
So yeah, the question is what kind of metrics we are trying to optimize. Generally speaking, for conversation, there are no consensus of what a good conversation is. Even for humans, it's not necessarily obvious what is a good conversation. Is it interesting, fluent, or anything? So there is no actually consensus on that. But we can think of, since we are thinking our product as a long-term companion, what we try to optimize is so the length of a session, so how many messages you exchange in a session, and how the long-term retention. Yeah.
What are the triggers for automatic retraining? Is very similar to those metrics?
So the question is, I guess, what kind of signal do we send for retraining something? It kind of depends what kind of models you're talking about. So if you're talking about the Bayes transfer learning, we're definitely not doing that every day, because just one epoch can take more than a day. So we usually do like maybe every month, so that we can gather all the data and like feed them to the model. For smaller models, it's just like when we change the training sets or the content. Yeah, there's a question over there.
How do you manage models that grow like so large that they might not fit into memory or something like that? Like, do you have a certain time you decide to redo the base training based on size or anything like that?
So the question is about size. Size matters, I guess. Yeah, that was a really bad joke, sorry. We haven't really had this issue right now. First, because our base model is already big, and we're just adding some really shallow classifying on top of that usually. So it doesn't grow exponentially.
Do we have any questions? One more. Do you guys integrate any kind of computer vision? Like, are you seeing if the response versus loud versus face or anything like that?
Oh yeah, teams can actually trace selfies. So we definitely have some computer vision pipelines behind it.
Does that influence like the language generation at all?
Yeah, definitely it does. So like the generation is based on everything that you can extract and understand.
Yeah, let's go that way and then come back.
Yeah, there's a question here on the couch. No?
I have a question.
Yeah.
How does HuggingFace make money off of this product?
So we take cash, credit cards, and also bank checks.
Like the team pays for the experience of chatting with the
No, they don't pay anything. Right now, we're making 0 revenues.
We do advertising.
No, we are mostly like in the mindset of building a consumer product, so making it big, and then we'll figure out how to monetize it.
We had one more over here. So you mentioned you did reinforcement learning and that you have like a big data set of conversations back and forth. When you first got started, what was your base data set, or what was the base data set you used to train the model before you had all these conversations?
So there are some datasets out there. There are some public datasets out there, like based on Twitter, on Reddit. They are pretty big, okay, but it's not really our use case. But you can already train something on top of that.
Yes, for maybe one more question if anyone has one.
Yeah, there's a question over there.
When you're retraining your model, how do you control for like quality of the data? Like you don't want maybe your model will learn say it's something language or stuff like that. How do you control check that your model is language model is not learning to use people fully?
I'm not sure I actually heard the
My
question.
question is
How do you avoid the take home?
how do you prevent your bot becoming racist?
Yeah, okay.
Prevent your bot from being evil.
So the question is how do we control the output of our bots and prevent becoming racist so that we are. So right now what we have in the version is that half of the generation is fully generative, like it's completely the model, and the other half is content-generated. So it's like some template that we fill with what we are able to extract from the NLU pipelines. But I guess that this really depends on what kind of training sets you have. And we have like some heuristic to